The lengths of pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. If one pregnant woman, so we have a single individual pregnant woman, is randomly selected, find the probability that her length of pregnancy is less than 260 days. Alright, so we know it's normally distributed, so everything that has to do with z-scores can apply here. Now, this is straight from section 6.3. This really has nothing to do with the central limit theorem in part A, because we know it's normally distributed and we're only talking about one woman. So we can just use the regular z-score formula. So here is our mean x bar is 268 days. So on the z-scale that would be a mean of 0. And we want to know the probability that our length of pregnancy is less than 260 days. So we're going to plug in 260 for our data value. Now subtract the mean and just divide it by the standard deviation, which is 15. So -8 divided by 15 gives us a z-score of -0.53. So we'll put that right there. So 260 days would correspond right above it. So there would be our 260 days. Okay, so we want to know the probability that a woman's pregnancy is less than that. Okay, so we just need to find the area to the left of a z-score of -0.053. So let's do -6 because we're talking about z-scores. And we're getting 0.2981. So the probability that z is less than -0.53 is 0.2981. So let's write that out. So we'll say the probability that one woman's pregnancy lasts less than 260 days is 0.2981. So the probability that one woman's pregnancy lasts less than 260 days is 0.2981. So I wouldn't really say that's likely, but it's definitely not unusual for one individual woman to have a pregnancy that lasts less than 260 days. Alright, let's look at part B. Now it says find the probability that the lengths of pregnancies of a group of 25 randomly selected pregnant women have a mean that is less than 260 days. So at first we were just finding the probability that one woman had a pregnancy length less than 260 days. Now we're saying what's the probability that if we grab 25 randomly selected women that their mean pregnancy length is less than 260 days. So remember, the probability that just one woman had it was 0.2981, which is not very likely, still not unusual, but not very likely. So what's the probability that all 25 of them will also be less than, the mean will also be less than 260 days. So notice now our x changed to x bar because now we're doing sample means. So we're taking several, many samples of 25 over and over and over and over again. So many samples of 25 over and over, and then we're taking the mean of those means to get our middle value right here. So a couple things here. First of all, our n is 25. Yes, that's less than 30, but it's okay because we were told it was normally distributed, so it doesn't have to be greater than 30. So that means that the population mean is the same as the mean of the sample means. which in this case is 268. So right here, the mean of our sample means is 268 days. So that would correspond to a z-score of 0. So now what we want to do is we want to find the probability that the whole group of women would have a mean less than 260 days. So now we have to use our formula that's for a group, not just for an individual value. So it's the mean, it's the mean that we're looking for, which would be 260, or the mean that we're proposing, which would be 260 days, minus the population mean, over the standard deviation, which is 15, divided by the square root of n. So divided by the square root of 25. So it's going to be negative 8 in the numerator. This is 15 divided by 5, so that's 3. So my z-score is negative 2.67. So now, a z-score of negative 2.67, that's going to be way over here. So that's going to correspond to a sample mean of 260 days. Now, before we continue, let's just compare these two graphs. Okay, I tried to line it up so the means were right on top of each other. So I got pretty close. So you can see how 260 days up here for one woman wasn't that unusual. I mean, it was a usual value. But now that we're talking about a group of 25 women, standard deviation is smaller. So notice how far out a average of 260 days is. So now that's very unusual that all 25 women would have a mean that's less than 260 days. So for one woman, not so unusual. Group of 25 women, that's pretty unusual. Let's just see how unusual it is. So we want the probability, so we want less than 260 days, so that would just be this little tiny area right here. Probability that z is less than negative 2.7. So we're just talking about z-scores. So we can go negative 6, negative 2.67, 0.0038, which is definitely unusual, less than 0.05, so that's definitely unusual. So let's interpret what that means. So we'll say the probability that the mean length of pregnancy for a group of 25 randomly selected women, the probability that the mean length of pregnancy for a group of 25 women is less than 260 days is 0.0038. Very unlikely that you would find 25 women and that their mean pregnancy length would be less than 260 days. Alright. So now let's look right here, part C. It says, suppose a group of 25 randomly selected women are put on a special diet before they become pregnant. If these 25 women do have a mean pregnancy length of less than 260 days, does it appear that the diet has effect on the length of pregnancy, and should the doctors or medical supervisors be concerned? So let's just refresh our memory. Up here we saw how unlikely it is that by chance 25 randomly selected women would have a mean pregnancy length less than 260 days. So now we're saying, let's say it actually did happen. We know how low the probability is, but let's say it actually did happen. Do we still believe that it happened by chance? So that, again, this is where the rare event rule for inferential statistics comes in. No, something else had to affect it. I really don't believe that we got something this low of a probability by chance. So it would appear that the diet would have an effect. So if all 25 of those women were put on the diet and their mean pregnancy length was less than 260 days, which is such a low probability, something else was affecting it. Okay, so for part C, we're going to say that it does appear that the diet has an effect on the length of pregnancy because the probability that the mean length is less than 260 days is so low. We don't believe that it happened by chance. So the medical supervisors should be concerned about the effects of the diet. Okay, so if they know that one of their patients is on this diet, they should be concerned. That should raise a red flag. That should say, hey, this is going to shorten the length of your pregnancy, which could be harmful to your unborn child.